Assalamualaikum warahmatullahi wabarakatuh. So this week is the fourth week, week 4, and finally we arrived to the new chapter, which is chapter 2, which is about differentiation. So in this chapter we will study about the differential calculus or the differentiation in calculus, which is about how one expression change into another expression. Actually, the concept of differentiation in calculus is from the idea is come from the slope of the tangent. So how is it related? I mean, what is the relationship between differentiation and slope of tangent? So we look at this page, which is in page 27. 27. So we look at the definition of derivative. Actually, the idea of derivative and the idea of slope of tangent comes from the limit, limit of a function. And from the previous chapter, we have discussed about the limit of function. So in this subtopic, we'll try to find the tangent. Using limit. We look at definition 2.1 on the same page. Let's say we have a curve which the function of the curve is f of x. So let's say this is the curve of f of x, and then at this point we have a tangent here, tangent line. You know what is the tangent line, right? Tangent line is the straight line which overlapping at one point on the graph. So we want to find what is the slope of this tangent line. So you know that tangent line is a straight line. So the equation of straight line is y equal to mx plus c. Then we want to find what is the value of m for this tangent line. For this tangent line, we want to know what is the slope, what is the value of m. So the value of m we can get from this equation, which is limit h tends to 0 for the function f a plus h minus f a divided by h. From where did they find this formula? Actually, this formula is derived from definition 2.2. In definition 2.2, we have this formula, which this formula is called as differentiation from the first principle. The first principle of differentiation. So the formula is f prime x equals limit h tends to 0 f x plus h minus fx divided by h. What's the difference between these two equations? You can see here the difference is we just change the unknown a into x. A changed to x, so we will get this formula, and m is equals to f prime x. It means that we can get the value of m from the differentiation of the function. Because m is equal to the differentiation f prime. So nak cari m, so we need to differentiate this function, and then insert the value of x here, so we can get our value of m. Now we will try to understand the concept of the differentiation from the first principle. Or we always call this formula as the first principle of differentiation. Ada perkataan the first principle. Okay, kenapa ada the first principle? Okay, because this principle is the basic. Okay, is the basic of the concept of differentiation in calculus. If you understand this concept, okay, it will help you to apply derivative to various function easily. Okay. Okay, so how is the procedures to use this formula? Okay, we look at here in step 1. Okay, you are given a function. Okay, you are given a function f of x. So you need to write the given expression in the form of f x plus h. Okay, the original function is f of x. So you need to find what is your f x plus h, meaning that all the variables x you need to add with h. Okay, let's say for example you are given f of x equal to x squared. So you need to find what is your f x plus h. All you need to do is just you take the original variable, which is x. Okay, so you need to add with h. So x squared, okay, akan jadi x plus h square. Another example, if you are given a function like 2x, okay, so you need to find what is your f x plus h. Your x plus h is 2. Okay, you take this variable and then add it with h. Okay, another example, if you are given a function like this, your f of x is 2x squared plus 4x. So what will be your f x plus h? Okay, it will be 2. Okay, x plus with h, and then square, and then plus 4, and then x plus h. Okay, from these 3 examples, you can see that all the values of x, okay, the original variable dia, kita add with h. Okay, x tukar jadi x plus h. So it is very important that you need to find the correct fx plus h. So you will insert the formula here. Okay, function yang kita dapat ni dekat sini lah. Okay, so if you get a wrong fx plus h, so you will insert the wrong function here, and then when you calculate this formula, okay, you will get a wrong answer lah. Okay, so that's the first step. You need to make sure that you find the correct fx plus h. Okay, and then for step 2, okay, write the expression write the expression fx plus h, okay, minus fx. Okay, because we need to find the term in the numerator. Okay, sama kan, fx plus h minus fx. So kita cari inilah. Okay, meaning that the expression that we found in the first step, okay, this one, minus with the original function. Okay, yang fx plus h kita cari tadi tolak dengan function asal. Okay, so kita dapat yang term yang atas ni lah. And next, for step 3, okay, you write the expression fx plus h minus fx divided by h. Okay, maksudnya kita dah cari yang ni atas tadi, and then this expression you divide with h, and then you need to simplify the expression. Okay, next page. Okay, for the final step, you need to solve the limit. Okay, that's the expression yang tadi. Okay, letak limit h tends to 0. Okay, let's take a look one example here. Okay, you are given this function, okay, f(x) equals x squared plus 3. Okay, so you need to find the derivative, meaning that you need to differentiate this function, but it is not a direct differentiation. Okay, you need to differentiate this function by using derivative from the first principle. So you need to use that formula lah yang tadi yang formula differentiation of from the first principle. Okay, so our first step is we need to find what is our f(x) plus h. So our f(x) plus h is, okay, you just change the x into x plus h. So we get x plus h squared plus 3, and then simplify this expression. We get x squared plus 2xh plus h squared plus 3. And then for the second step, okay, we need to find f(x) plus h minus the original function. So our f(x) plus h is here. Okay, masukkan ke sini, and then minus with the original function, which is here, x squared plus 3. Okay, tolak kan. So akan jadi x squared plus 2xh plus h squared plus 3 minus x squared minus 3. So when we simplify this expression, we'll get 2xh plus h squared. Okay, because we can cancel out x squared and 3. Okay. Okay, then for the third step, we need to divide this expression with h. Okay, yang tadi kita dah tolak kan, dah tolak, akan jadi 2xh plus h square, and then divide with h. Okay, when we want to divide with h, we can factorize the upper term. Okay, factorize, keluarkan h, and then cancel out upper and lower h. Okay, so the resulting is 2x plus h. Okay, so we insert into the first principle of differentiation, which is this formula. Okay, f prime x equals this expression. So limit h tends to 0. So this expression tadi kita dah simplify daripada first step, second step, and third step. So kita dapat 2x plus h. Okay, 2x plus h. So just insert the value of h equal to 0. So we get 2x. So the answer is 2x, meaning that the differentiation or the derivative for x squared plus 3 is 2x. Okay. Okay, let's take a look at another example. Okay, this time we have the function that has cert here. Okay, cert. So this is the first step. We need to find what is our f(x) plus h. So just substitute x with, okay, change x into x plus h. So we will get x plus h plus 1 cert minus 2. Okay, and then continue with our second step. What is our second step? We need to subtract. Okay, subtract f(x) plus h, okay, with f(x) plus h, this one, and then minus with the original function. Okay, like this. Okay, this is our f(x) plus h, and this is the original function. Okay, and then kita simplify. Okay, simplify. Square root x plus h plus 1 minus 2, and then minus square root x plus 1 plus with 2. Sorry, this is plus 2. Okay, because negative with negative will become positive. Okay, and then 2 will be diminish. Okay, kita dah boleh cancel out. Okay, positive 2 plus 2 equals 0. So the remaining term is this one minus this one. Okay, this is our second step. Okay, and then for third step, we need to divide this expression with h. Okay, so continue with next page. Okay, so kita bahagi dengan h and then simplify. Okay, this expression kita nak simplify. So in order to simplify, we need to conjugate. Okay, multiply with the conjugate of the yang term yang ada square root ni lah. Okay, so that dengan conjugate, and then it will become this one. Okay, the third yang bahagian numerator tu akan hilang. X plus h plus 1 minus x plus 1. Okay, and then we can cancel out 1 and also x. Okay, so the remaining term is h, so we can cancel out up and down. Okay, h atas bawah tu. So this is the simplest form. Okay, so bila dah dapat ni, kita letak limit depan dia. Limit h tends to 0. Okay, lepas tu letak yang ni. Just kita tambahkan limit je. Limit h tends to 0. And then insert the value h 0, kita masukkan h equal to 0. So we will get like this, and try to simplify this form. Okay, square root x plus 1 plus with square root x plus 1 will get 2 square root x plus 1. Okay, so this is the simplest form, meaning that the derivative or the differentiation for this function is 1 over 2 square root x plus 1. Okay, now we will take a look at another example, because we want to know the relationship between differentiation and tangent line. Okay, tangent line yang macam saya explain tadi. Okay, look at example 2.3 on page 29. Okay, the question is find the equation of tangent line. Okay, to the curve. Okay, this is the curve at point 11. Okay, meaning that we have this curve x square. Okay, dekat point sini, which is 1, 1. Dekat point yang ni lah maksudnya, point yang ni. We want to find, we have a tangent line. Okay, kat sini, kat point ni. So we want to find what is the equation of this tangent line. Okay, so as I mentioned before, every tangent line is a straight line. It's a straight line. So if we want to find the equation of tangent line, meaning that we need to find what is our y equal to mx plus c. Okay, first we need to find what is our m. Okay, where m is the slope of this tangent line. Okay, so from the previous page, okay, I have mentioned that this is the formula for the first principle tadi, first principle. Okay, dalam first principle, dekat sini dia letak f prime x, right? F prime x equal this one. So as I have mentioned before, f prime x is equals to m. So if we want to find m, okay, what is m? M is the slope. Okay, slope of the tangent equation of tangent line. So in order to find what is our m, so we need to find the differentiation. Okay, the differentiation of this function. So in order to find the differentiation of this function, we need to use the first principle. Okay. Okay, and one more thing. There is a difference. If you look at this formula, there is a difference between formula dekat dalam first principle just now. Okay, where in the first principle we use variable x kat sini. Okay, x. But this time we change our x into a, where a is the point here. Okay, A is the point here. Okay, the point of X. Okay, bukan point yang Y point yang X kan, kita dalam koordinat XY. So A is the value of our X. So in this question our X point is 1, so our A will be equal to 1. Okay, then we will conduct the steps yang step 1 until step 4 yang just now tadi. Okay, so the first step is from the previous examples. The first step is you need to find what is your X plus H, but in this case our X is 1, so meaning that you need to find what is our F 1 plus H. Okay, so what is our F1 plus H, meaning that, okay, just now you are given Fx equal to X squared. So Fx here is Fx. So if you want to find what is F1 plus H, meaning that you need to change all of your X into 1 plus H. Okay, so F1 plus H is equal, X ni gantikan dengan 1 plus H. So we will get 1 plus H square, and then expandkan dia akan jadi 1 plus 2H plus H square. Okay, this is first step. And then second step, okay, second step, from the previous examples, our second step is we need to find this expression, okay, where Fx plus H minus with the original function. But in this case, okay, kita tukarlah X kita 1 kan tadi, F1. Okay, so kita nak cari inilah. Okay, F1 plus H kita dapat daripada yang tadi, iaitu yang ni, minus F1. F1 means that ini original equation kita tadi. So kalau F1 meaning that we need to change X into 1. So X ni gantikan dengan 1. So it is equal to 1. So jadi minus 1 square lah kat sini So it will become 1 ni boleh potong. Okay, 2H plus H square. And then this is the third step. The step, if you remember, our third step is we need to divide, okay, with H. Okay, divide yang kita dapat tadi ni, divide with H. Okay, and then simplify. So dekat sini kita factorize our H, and then potong-potong jadi 2 plus H. And then finally for the fourth step, okay, sama macam yang tadi examples, the previous examples, we need to insert the limit. Okay, limit H tends to 0. Okay, so masukkan yang ni lah, 2 plus H. So jawapan dia adalah 2. So meaning that our M is equal to 2. Okay, M equal to 2. So tadi kita tahu the equation of tangent line is y equal to mx plus c. So our y is 1, okay, from the coordinate given here. So our y is 1 and our x is equal to 1 also. And then our m yang kita dapat tadi equal to 2. So from here we can get the value of c. Therefore the equation of tangent line is y equal to 2x minus 1. Okay, that's the relationship between the differentiation using the first principle and the concept of tangent line. Okay, where we can get the value of slope of that tangent line with using the formula for first principle, okay, differentiation tu. Okay, and then we proceed with the next subtopic, which is the techniques of differentiation. Oh, sorry, saya terlupa one thing. Yang tadi formula first principle, okay, first principle, nama dia adalah differentiation from the first principle, or the other name is the definition of derivative. Okay, so kalau dalam exam ada satu soalan tu, dia kata differentiate the following function with using the first principle, okay, atau with using the definition of derivative. Okay, so meaning that you need to differentiate the function given with using this formula, okay, not the direct formula lah, okay, formula yang ni, bukan cara yang direct tu. Okay, apa maksud yang saya kata cara direct? Okay, cara direct tu adalah cara ni, okay, with using techniques of differentiation. Okay, so in this section we will learn about how to differentiate functions with using a direct method, okay, not using the first principle. So for that we have several theorem here. Okay, the first one is theorem 2.1 on page 30. Okay, this theorem is for the differentiation of constant function. Okay, constant function, the function that didn't have variable. Okay, for each of the constant function, if we differentiate that function, it will become 0. Okay, and then second theorem. Okay, before second theorem kita tengok yang ni. Okay, differentiating a constant function, which is a function without the variable. Okay, as I mentioned before, constant function is the function without the variable, tak ada x. Okay, contohnya function dia f of x equal to 3, f of x equal to negative 5, f of x equal to 7. Okay, all of that functions, if we differentiate them, okay, it will become 0. Okay, same with this function. Okay, function of pi. So pi pun constant, okay, but it is equals to 3.14 something. So if you want to differentiate the function of pi, it also will become 0. Okay, then we look at this theorem, theorem 2.2 is the differentiation for positive power function. Okay, there is the function in the form like this, x power of n, where n is the positive power. Okay, for example, x square, x cube, x power of 5, okay, x power of positive number. Okay, for all of this function, if you want to differentiate them, okay, we will use this theorem, okay, and bring it in front, and then power kat sini will minus with 1. Okay, so this is the concept for differentiation of function with positive power. Okay, for example, if you want to differentiate x power of 5, so 5 bawa ke depan, and then 5 minus 1, it will become 5x power of 4. Okay, this theorem can also be used when n is not an integer. Okay, n integer, maksudnya n ni tak semestinya nombor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boleh juga kalau contohnya n dia tu kuasa setengah, 1/2 macam ni. Okay, as long as the power is positive. Okay, power positive, so we can use this theorem. Okay, x power of positive number, no matter that positive number is fraction or decimals, as long as it is positive, so we can use this theorem. So for differentiate x power of 1/2, so we use the same concept, 1/2 bawa ke depan, and then 1/2 minus with 1. Okay, so we'll get 1 over 2 x power of negative 1 over 2, so it will become this one. Okay, the third theorem is for differentiation of constant multiples. Constant multiples. Okay, meaning that the function kita ada constant c dekat depan function tu. So if you find the function like that, so how do you differentiate this function? So yang constant c, just bring it in front, and then you just differentiate the function yang belakang tu. Okay, constant tu biarkan dia. Okay, for example, we want to differentiate this function for x power of 7. Okay, for x power of 7. So the constant here is 4. So 4, bring it in front. So you just need to differentiate x power of 7. Okay, so 4 biarkan dia. So to differentiate x power of 7, we need to use this theorem. Okay, konsep yang tadi ni. Okay, so it will become 7x power of 7 minus 1. So 7 ni we can multiply with 4. It will become 28x power of 6. Okay, so meaning that x we can bring it in front, or we can factor 4. Okay. Okay, another example. Negative 5x power of negative 3. Okay, our constant here is negative 5. So negative 5 kita factor out dulu, and then we just need to differentiate x power of negative 3. So negative 3 being bawa ke depan, and then negative 3 minus 1. So it will become negative 3 x power of negative 4. And then negative 3 will be multiplied with negative 5. So it will become 15. Okay, 15x power of negative 4. Okay, and then theorem 2.4. This theorem said that if you have two functions, okay, with the relation of plus or minus here, okay, two function, this function plus this function, or this function minus this function, okay, you have two functions, so you can split out, okay, differentiate with the first function, and then plus or minus differentiation of the second function. Okay, this process is called the sum and difference rule. Okay, for example, okay, we have this function x squared minus 2x plus 1. Okay, here we have three functions where the first function minus the second function, and then plus with the third function. So we can differentiate it one by one, term by term. So differentiate x squared, okay, will become 2x 2 minus 1, and then minus, okay, differentiate 2x, okay, 2 is a function, is a constant, so we can bring it in front, okay, negative 2, and then x, here is x power of 1, so we can use power rule, x 1 minus 1, okay, and to differentiate 1, okay, 1 is a constant, so each time you differentiate just a constant without variable, so it will become 0. So simplify all of this, we will get to x minus 2. Okay, notice that when we differentiate x power of 1, it will give us x power of 0, okay, which is equal to 1. So you can see here, the original one is x power of 1. So when we differentiate it, it will become x power of 0, okay, where x power of 0 is equal to 1. So it will become negative 2 lah kat sini. Okay, and then theorem 2.5 is the differentiation of products. We have two functions here that is the product of each other. Okay, we call it as product rule. Okay, product rule. So kita ada u times dengan function v, and then we want to differentiate this function. It will become u differentiation of v plus v differentiation of u. Okay, I repeat, u times with multiply with differentiation of v, and then plus v multiply with the differentiation of u. Okay, or simply f prime x, okay, equal to u v prime plus v u prime. Okay, this is called product rule. Okay, look at this example, which we need to use product rule. Okay, because here we can see we have two functions that is multiplied each other. Ni darab dengan ni. So we assume u, okay, is equal to this function, and this is our v. U times v. Okay, this is our u and this is our v. And then we need to find what is our u prime and v prime, because we have u prime and v prime in the product rule. Okay, u prime will insert it here, and v prime we will insert it here. So our u prime is from here. Okay, our u prime is 12x squared. Okay, and our v prime is from here, which is equal to 5. And then insert it in the product rule. Okay, this is our u times v prime plus v times u prime. Okay, just simplify all of this. Okay, we will get 20x cubed minus 25 plus 60x cubed, okay, plus 12x squared. Okay, and it is equal to 80x cubed plus 12x squared minus 25. Okay, for this kind of function, if you don't want to use product rule, okay, if you don't want to use product rule, you can simplify this function first. Okay, meaning that you need to expand this function. So our f of x will become 20x power of 4. Okay, and then plus with 4x power of 3. Okay, power of 3 minus 25x and minus 5. So this time you need to, for this function, for this simplified function yang kita dah expand, you don't need to use product rule. So just differentiate it one by one, term by term. So for differentiation of 20x power of 4, you just need to bring 4 in front and then multiply with 20. So it will become 80. 80x power of 3, and then plus, okay, 3 bring it in front, so it will multiply with 4, and then we get 12x power of 2, and then this one will become minus 25 plus 0. So it will become 80x cubed plus 12x squared minus 25. Okay, you can see here the answer is same with this answer, which we use the product rule. Okay. Okay, next theorem is theorem 2.6. Okay, the differentiation of quotient. Okay, if you have this kind of function, which is the two function u and v that divide each other, so we can use this formula. Okay, we call this as quotient rule. Okay, the formula is f prime x equals vu prime, okay, minus uv prime divided by v squared. Okay, we look at one example that we need to use this quotient rule. Okay, example 2.6. Okay, we need to differentiate this function. Okay, 3x squared minus 2x divided by 4x plus 3. So we can assume these terms as our u and these terms as our v. Okay, make sure the numerator is u and the denominator is v. Okay, tak boleh terbalik. Okay, the upper part is u and the lower part is v. Oh, sorry. Sekejap Okay, so for this question, our u is 3x squared minus 2x, and our v is 4x plus 3. So we need to find what is our u prime and v prime, because we want to use this formula. So we will insert u prime here and v prime here. So our u prime will be 6x minus 2, because we are differentiating this function. So it will become 6x minus 2. And for v prime, it will become 4. Okay, and then just substitute it into the quotient rule. Okay, make sure you substitute it correctly. We need v and then u prime. Okay, v u prime minus u v prime divide by v square. And then next step is you just simplify all of this. So you'll get 24x squared and then minus 8x plus 14x minus 6. Okay, minus with the terms here. Okay, 12x squared minus 8x. Okay, and then simplify all of this, and then the answer will be 12x squared plus 18x minus 6 divided by this term. Okay, v squared. Okay, it is better to leave the denominator unexpanded. Okay, tak payah expand yang denominator. Okay, we just need to simplify the rational function. Okay. Okay, if the function has a denominator that is not a function of x, meaning that our denominator, the lower part of the fraction, is not in the function of x, tak ada variable x, it is easier to differentiate by using theorem 2.3. Okay, kalau macam example ni, okay, our fraction here, the denominator form yang the lower part, okay, kita ada variable x. Okay, and for this example, okay, kita tengok denominator bahagian bawah tak ada variable x. Okay, so kita buat macam mana? Okay, so if our denominator, the lower part of the fraction, is constant, okay, meaning that we have no variable in the lower part of the fraction, so we can yes, you can use quotient rule, but the working solution will be a bit longer. So the simplest way is you just simplify it as 7 over x. Yes, 7 over 8 x power of 8. Okay, kita tengok yang tadi Okay, this one. Okay, it will become 7 over 8 x power of 8. Okay, so we can just differentiate this one using the power rule tadi Okay, so you just bring this power in front. Okay, and then 8 minus with 1. So 8 kita boleh cancel out. It will become 7 x power of 7. Okay, and then this theorem, theorem 2.7, is the theorem for the higher order of differentiation. Okay, based on all the previous examples, okay, we just differentiate each of that functions once, differentiate sekali saja. Okay, higher order differentiation means that we want to differentiate the function more than once. Okay, for example, this function is to differentiate the function twice. Okay, ada f double prime. Okay, meaning that we differentiate the function twice. And f triple prime, meaning that we differentiate the function thrice. Okay, okay, for example, look at this example. You are given this function and you need to differentiate it 4 times. Okay, because we have 4 prime. Okay, 4 times. So differentiate it once, okay, will become 4x cubed plus 6x square, 9x square minus 10x minus 24, and then differentiate it twice, okay, meaning that we are differentiating this function, okay. So differentiating that, we will get 12, okay, x square plus 18x minus 10, and then differentiate it again, we will get 24x plus 18, and differentiate it again, we will get 24. So the answer will be 24. Okay, that's all for the syllabus in week 4. And for the next week, in week 7, we will learn about the chain rule, okay, chain rule, and how to differentiate the functions involving trigo, log, okay, trigo and log. Okay, so that's all for this time. Okay, I will end this video. So if you have questions about what we are learning today, so just text me on Telegram. Okay. Assalamualaikum warahmatullahi wabarakatuh.